Hi, in exercise WT-2 we have the honor to design 3 different wind turbines, and the load parameters of the turbines are given, so they are of a different power, and usually the speed of a turbine with higher power is lower. So for 3 megawatt we have just 15 RPM, while for half megawatt turbine we have 20. So the over speeds are the same and grid voltage is the same for all the 3 turbines. And we are designing for lowest cost here. So we have the freedom to play with the electric machine types and different gearbox types and ratios. So for each of the turbines we can experiment with the placement of our equipment in the tower, by the tower. So the tower height is 100 meters, it's the same for all the 3 turbines, and we can place all the components inside the nacelle, so including the frequency converter and the transformer, and have just the high voltage cable going down the tower of the turbine. And we also need to know that the powerhouse or the grid is located 200 meters from the turbine. It's like a substation, so we have to take this into account. So what we can do, we can place our frequency converter and transformer inside the tower, approximately halfway along the tower height. So it is like 50 meters above the ground and 50 meters from the nacelle. So this affects the cable length between the generator and the frequency converter. We also have the option to place our frequency converter and the transformer at the ground level in a container close to the turbine. So then the cable will be longer, the cable between the generator and the frequency converter. Let's now take a look how we can do this in DriveConstructor. So first, of course, we enter the parameters of the turbine. We take the smallest turbine first, and then we of course need to start with the frequency converter for quadrant and put in the right voltage for the grid, 10,000 volts. We can then try to experiment with the voltage level of the frequency converter. It can be 690 volts, for example, and the cable can be quite short if all the components are in the nacelle and there are just a few meters between the converter and the generator, or can be longer, like 55 meters if the frequency converter is in the tower halfway, and it can be longer if it's in the container. So what else? Filters, of course, can be WT or sinus filter for the machine side, and on the grid side we always have sinus filter. So the choice of filter will depend on the cable length, as you know, and the voltage level. This you can check in the textbook. And for the gearbox, of course, we can play with a number of stages and the types of the gearboxes. Remember, we are optimizing on cost, so we sacrifice the efficiency a little bit, and everything we need we can find in the report for each calculation. So look here are efficiencies. Maybe they are too low, maybe you want to improve it, and you first trace where the losses are, and they are in the cable, because maybe the cable is too thick, too thin, and then we need to go into the cable parameters and check whether it is true or not. The cross section is a bit too low. We go in and increase it to 240 square millimeters, and now efficiency is a bit higher than it used to be. So we can even go and increase it further and check again what happens. We can also try to reduce cost by choosing squirrel cage induction motor instead of permanent magnet machine, and do similar things. Thank you for watching, and good luck with exercise.